Hello, I'm Mr. Marseille from Outwood Academy, Acklam. In this video, we are going to look at lenses. It's a triple physics topic. You're going to need a couple of things before you start. You're going to need yourself a ruler, some paper, a pen, you're going to need a pencil, and you are going to need a calculator. If you haven't got a calculator, I recommend you download a scientific app to your phone. There's quite a lot floating around on the App Store or on Google Play, and you can find yourself a decent scientific calculator. Okay, so before you start, what I'd like you to do is pause this video, and I'd like you to have a go at these questions on the screen here. Okay, they are just recall questions. The more times that you engage with the previous learning that you've done, the more chance it has of staying in your head and you being able to recall it quickly and just being able to know it. So I'm gonna wait for 5 seconds, then I'm gonna let you pause the video. When you're ready, I'll reveal the answers. Okay, that's enough time. Right, here's what you should have got. Get yourself a red pen and check these. If you got them right, tick them. If you have not, it's really important that you change them, because by changing them and engaging with them, it's more likely that you'll remember these. Okay, I'm not going to read them to you. You can read them yourself. And if I'm moving too fast, again, just pause me. So in this lesson, we are going to, as I said, look at lenses. The challenge objective is to be able to draw ray diagrams for lenses. So we'll explain what that is later in the video. And the aspire is that you can describe the image formed in a convex and a concave lens. Again, we'll look at what a convex and concave lenses are within the lesson. And we're going to calculate some magnification. Okay, so let's start off with this. What is a lens? Well, a lens, as it just says on the PowerPoint there, is a piece of transparent glass or plastic that refracts light. And we should have done refraction before. It was on the starter. That's why it's important to do that. So refraction means that it causes light to slow down or speed up depending on the density, and therefore change direction. So a lens changes the direction of light. And we'll just see that that's due to its density. Now, here's an image of a lens. It looks quite complicated at this point. So we can see that there's this stop sign here, and then that goes into your eye. Now your eye contains a lens, and your eye then changes the direction. You see how these lines are coming closer together of this light, which causes it to be focused on the back of your eye. But there's loads of other different types of lenses. So we've got the one there, which is the one in your eye. We've got, that is a lens from a camera lens, just sort of looking through it. You can see that it's focused, this image that is otherwise out of focus of this forest. We've got contact lenses. So if the lens in your eye is not working correctly, if it's not focusing the image on the back of your retina, then what you would need to do is you would put a contact lens in, and that contact lens would change where the image was focusing. Another type of lens is a telescope. So telescopes are used in order to focus the light coming from very, very long distances away, so that you can observe planets, galaxies, whatever it is you want to look at with your telescope, really. Glasses, again, like a contact lens, used to correct vision in order to change the focal length of whatever you are seeing. A magnifying lens is used to make things bigger, so you can look at an image and it can appear larger. So that's another use of lenses. And cameras, and there are loads more, but they're just some of them. So lenses are really, really important, and you probably use them far more than you know. You're using them constantly because your eye is one, and I'm using one to record this video because I'm going to use a visualizer here, which has a lens in it, which is focusing this image. Okay, every time I press this button, the autofocus, there you go, the lens has done its job into focusing this image. So lenses are important. So there are two types, and they have special names: convex and concave. This is what they look like. So this is a convex. So you can see on this image we have got 4 light rays going in. This is a representation, but remember light travels in straight lines. So the light is going into the lens, and then the lens is changing the direction of the light, and on this red dot here, which we call the principal focus, the light is being focused, and that's where the image would be focused. So if that was, if this was your eye, that's where whatever you were looking at would be in focus. If your retina was anywhere else, it would be blurry. Okay, I'm not going to read that to you. You can read that yourself. But the key thing is that you know that this is a convex lens. So convex brings light together. So think of the word conference, okay? Or if you go to a conference, it's a coming together of people. So that's exactly the same. That's where that word comes from. Now, if we draw this on a ray diagram, it gets quite complicated. So what we can do is we can use this symbol. Okay, so I'm gonna just draw that. So actually, so this symbol, yeah, if we draw it, it looks like this. Okay, now we can see that in reality that symbol it's just the same as the lens, but we've just taken the middle part off. It just makes things a little bit less confusing when we draw a ray diagram. So let's write that. So that is a convex lens. Okay. The next one. So we've got a concave lens. Okay. Now, the concave lens, the another name for concave lens is a divergent lens. It makes things spread out, like if you go to diversion. So whereas the first lens, the convex lens, here, that focused the light, this concave lens actually makes the light spread out. And it can actually be focused behind, but we'll come to that later. Okay, so again, you can read that. And again, this is the symbol that you need to know. So again, get your pencil. So rather than drawing that full thing, what we do is we draw this. So the ends of the lens are drawn like that. Again, it's that shape of the lens that represents. So this is a concave. Okay, right. So time for you to do a little bit of thinking about what we talked about and a little bit of engaging with that information. So I'd like you to pause the video. I'd like you to write those sentences out on your piece of paper and complete that activity. And as soon as you are finished, make sure you're fully finished though. Don't do it if you aren't, because that will totally miss out on the learning. So finish the activity, unpause the video, and I'll go through the answers. I'm just going to wait for a couple of seconds. Okay, I've done waiting. This is what you should have got. You should have said that lenses cause light to refract. You should have said that there are two types of lenses and they are written here. So that was easy. Concave and convex. Either way around is fine. Sketch the lens in figure 1. So you should have drawn this in your book. And you should have said that that lens is a, wait for it, convex lens. Okay, it's convex because it's converging this light. And that's simple, which we already had drawn, but you might as well draw it again. Sketch the lens in figure 2. Again, you should have drawn this. And you should have labeled it as a concave lens with this symbol. And a little bit of challenge, what's this dot called? Well, this dot is called the principal focus. Okay, all the way from slide number 2. Right, let's move on. So this is the big part of the lesson, being able to draw ray diagrams from lenses. It's the challenge objective. You can see I put it in red. And this is, it's going to lead into this aspire as well. We can't do the aspire unless we can do this. So let's have a model. So this is the reason why I've got my visualizer out for this lesson and why it's so important and why this lesson won't work unless you see me drawing this, because you need to draw these two. So a convex, so it's a convex lens. So we're going to start with a convex lens. Now they've drawn, so this model has drawn the full lens. Now I don't like to draw the full lens, it gets a bit messy, so I'm going to do the symbol. So what you need to do is you need to get your ruler, and you need to get your pencil, and we're going to leave some space in our book. Now we're going to draw a lens, The first thing we're going to do though is we are going to draw on this line. This line here is called our principal axis. It's a straight line that goes through the very middle of the lens. And if it doesn't go through the middle, it won't work. So it has to be in the very center. So first thing I'm going to do is I'm going to draw my lens. I'm going to figure out how much space I've got. So I've got, let's say if I go from about here to about there, 15 centimeters. So I'm going to draw my lens exactly in the middle of that. So half of 14 is 7, and then a half to get to that 15. So I'm going to draw my lens here. All right, I'm going to do a bit of space. I'm going to have 3 lines above and 3 lines below. So there's my lens. And I'm going to draw on that axis, which I said was 15 centimeters, so 7.5 there. And these are really important that you do try and keep your scales correct, because we will be looking at the measurements of these. Okay, so you can see that my lens, I'm not drawing it very well, is drawn perpendicular, so at 90 degrees to this principal axis. I'm just going to focus that a little bit more so it's a little bit clearer. In fact, I might, there we go, let's zoom into that, because this is the bit that's important for us. So the other things you might notice are these little red lines. So you need to know what those are, and they're what we call our focal points. So when we looked at the image earlier, we saw that as the light went through the lens, it was brought to a focus, and that is the focus point. So we've got our first focus point. So what I would suggest we do is let's do that first focus point at 3 centimeters. So draw and make a mark at 3 centimeters from your lens. And the second red dot is a 2F, what we call 2F. That's just the length of 2 focal points. So we'll make that one at 6 centimeters. So that is F, and that is 2F. Now, lenses work in both directions, so we also need exactly the same behind, and the focal distance is the same, forward and backwards. So again, another 3 centimeters. So I'll just put 6 there. So 3 centimeters is my 1F, and then that one is my 2F. So that's the focal point, and that's 2 times the focal point. Okay, so we should have this so far. Make sure you're at this stage. So what happens now is, that's what I just explained there, the length and the focal length. So we're going to put an object. So this object could be absolutely anything that your eye is looking at is focused by a lens. But we're going to make this really simple for now. We're going to just draw an object and we're going to represent it as an arrow. The arrowhead is really important because it tells us which way up the image is. So I'm going to draw my, I'm going to use centimeters. So I'm going to go for a 2 centimeter image. Now, where it is really important. You can see that this image is described as being beyond 2F, which means it's further away than 2 focal distances. So let's have a look. Let's draw an image. Let's draw one that is 2 centimeters tall, somewhere beyond 2F. So there we go. And if I said that that's exactly 2 centimeters, my arrowhead has got to be exactly on 2 centimeters. Something like that. Okay, and let's label that. So that is the object, and it is 2 centimeters. That's really important because you can see as part of the Aspire objective, we need to calculate magnification. So we need to know the size of the object in order to do that. Okay, so what do we do next? Well, oh, we don't do that. This is what we do. We click on here and you can see that there's this line. I'm just showing you on and off. So this line here represents how we draw a ray diagram. So what we do is we go from the very top of the image and we draw a line that is parallel with our principal axis that goes into the lens. Okay. And then from here, from the center of that lens, oh, I just realized I haven't told you what type of lens this is. Look, there we go. Look, it's a convex lens. So we draw, our next arrow goes through the focal point, so through this point here. So we just draw that, and we just, in a straight line, and we just let it continue. Okay, so it looks something like that diagram. What we do need to do is we need to show which direction that this light is going, so we're going to include arrows to show that. Okay, we're going to build another line. The next line here goes, it's my favorite line, this one, because it's just simple and it's always the same. It goes from the top of the image right through the center of the intersection between the principal axis and the lens, and the center of the lens goes right through there, and you just line that up, and wherever that goes, you continue your line. Again, show the direction that the light is traveling. Okay, so we can start to see it already, even by just drawing these two lines, that we've got a point where our light is being focused. So this is where the image is going to appear. But we can draw a third line just to check that. But you only ever need to draw these first two, but I'll show you all three. So the next line looks like this. The reason it's dotted is just because it's an optional line. This one goes from the top through the focal point here, the one on the same side as the image, sorry, the same side as the object, and hits the lens. And again, you should see, depending on how good your drawing is, mine's a little bit wrong there. All right, there we go. So it's, yeah, if you get your scale a little bit wrong, this line doesn't always work. That's a terrible job, but there we go. Okay, so that goes through the image. Now we can see that all of our points are focusing there. So that was the top of the object, and this one here must be the top of the object. So we're going to draw our line down. We're going to put our arrowhead in as well, so it looks exactly the same. And we now see, as you see here, that this is the image that is produced. So let's have a look at this image, because the Aspire says that we have to be able to describe the image formed in convex and concave lenses. So this is a convex, and this is the image form. So let's try and describe that image. The reason I do this in pencil is because what you would do is you wouldn't leave your diagram like that. You would get a rubber and you would sort it out. In fact, I'm going to do that right now. I'm going to press the pause button. I'm going to come back and I'm going to sort out that, sort out this ray diagram. Okay, there we go. And if by magic, the ray diagram has fixed itself. I did realize that I haven't told you which way the light's going. So we needed to make sure that that arrow goes on there too. So let's have a look at this image. So we can see that this image is upside down. That's the first thing we can see. This one was pointing upwards and this one is pointing downwards. So we could say that the image is, use the fancy word, inverted. So an image could be inverted or the right way up. This way is inverted. The next thing we need to look at is whether or not it's got bigger or smaller. So we measured the first one as 2 centimeters. Let's measure this one. This one is 1.6 centimeters. And that is the image. So it's got smaller. So the word that we use for that is the word diminished. Okay. And the last thing that we need to look at, if it's in this orange box here, is whether or not it's real or whether or not it's virtual. It's a bit of a strange explanation, this. So a real image is one that is formed on the opposite side of the lens to the object. So imagine you're looking through a window, you look through that window and you see something on the other side. If you were to reach through the window, you would be able to grab that object. It's real, okay? If you're looking in a mirror, you can't reach through and grab the image that you see. It's not really on the other side, even though it looks like it is. Okay, so that's what we call a virtual image. So a real image is one that is on the opposite side of the lens to the object, and a virtual image is one that actually appears on the same side of the lens to the object. And we'll have a look at those when we look at the ray diagram for a concave lens. Okay, so we've reached the part of the lesson now where it's time for you to go on and have a go at this on your own, to do some independent practice. So this table here, I want you to copy this table into your books, and you're going to fill in these three columns here, because the Aspire objective says that you can describe the image. So we're describing it for its size, its orientation, and if it's real or not. And these are all from the convex lenses. The concave lens we'll do at the very end. We're not going to do the magnification column yet, because that's a skill that we still need to look at. So we've done outside 2F, and I've put that image here so you can see. So we've got a model of exactly what you need to do in case you want some reference. So these should be dead easy to fill in this first column here. If you know what you're doing, then you don't need to watch this part of the video. So just pause it and get yourself somewhere nice and quiet, get distractions away, and make sure you've got your equipment set up, and just take your time with these drawings and go through and try and do each one. What I will do is I will do the at 2F one now, in case you feel as though you need a little bit more practice. Again, at any stage whilst I'm doing this, just stop, pause the video, and you can carry on your own. So first off, we're going to draw our principal axis. So our principal axis, remember, is just a straight line. We're going to put our lens in the middle. And we'll do 3 above, 3 below. And they're all convex. So convex, we put that symbol on. And we'll do the same focus points on the last time. So we'll have a 3 centimeter focal point, which means that we have a principal focus at 3 and 2 principal focuses at 6. Make sure we've got those nice and accurate. Again, on this side. So 3 and 6. Label those. F, 2F, F, 2F. So our image now needs to be at 2F. So dead on this line. And we're going to make it nice and easy, nice easy numbers. We'll have a 2 centimeter image. So don't use the lines in your book, because the books aren't quite each a centimetre. Make sure it is 90 degrees, so it's perpendicular. There we go. I've missed slightly, but that is close enough. I've just got a very sharp pencil, that's all. So if you know what to do, you can get on with that. If not, we can do it together. I'm going to zoom it in so we can see exactly what's going on. And I'll just press the focus. There we go. So we'll draw our first line, which is a straight line parallel with the principal axis into the lens. Put on the arrowhead to show the direction. Then we've got from where it's hit the lens through the principal focus, and just carry that line through, showing again the direction. And then the next one, this is the only one we're going to draw here, is from the very top through the middle. Okay, and you can see the direction, and these images have found a point here where they have converged there. So you should see that that is exactly on 2F. That was the top, so that's now the top. So it's not exactly the same image because it's now inverted. So if you know what you're doing, pause the video. I'm just going to go through now, and this is what you should be writing in your table. So the size, well, this was 2 centimeters. So let's label that on. So that's 2 centimeters. Remember, this is the object. So this is the image, and it is also 2 centimeters. So for the first one, the size is neither diminished or magnified, it's the same size. Okay. Orientation. So is it inverted or is it upright? Well, it's been flipped round, so we say that it's inverted. And the last thing, is it real or is it virtual? Well, it's on the opposite side of the lens, therefore it is a real image. Okay, so that one here was at 2F. Let's make that a subheading. So I'd like you to now carry on, go through, have a go at the between 2F and F. At the F, I'll give you a little heads up now. The F one, you will produce something that you will not be able to focus. If you do that, then you've got it right. And the closer than F, you will produce an image where you will have to trace it backwards. You might get a little bit stuck there, but don't worry, when I'm going through the answers, I will show you exactly how I solved that. Okay, so pause the video now because I'm about to go through the answers. I want you to make sure you've drawn the diagrams and completed your table first. I'll do this for a second. That's enough of that. Okay, so object at 2F is what we've just drawn. And you should have produced that, which, as we've just drawn, says it's real, it's inverted, it's the same size. So this is the first one you should have drawn on your own. So between F and 2F, so anywhere between there will produce an image that looks like this. First line, and there. So what we've got is we've got an image that is, wait for it, there we go. It's real because it's on the opposite side of the lens. It's magnified because it's much bigger, and it's inverted because it's flipped upside down. Okay, this is the one I said would be a bit weird. It shouldn't have focused, and this is why. Image here, line hits the lens, goes through the principal focus. The next one, it goes through the center of the lens, and you notice that these two lines are parallel. What I mean by parallel is that they're never going to meet, which means if we can trace them forwards, they're never going to meet. If we trace them backwards, behind the line, they're never going to meet. So we cannot produce an image at F. So no image will be produced there. Okay. Right, now this one, object inside F, this is the one which will have looked a bit strange. So we do that line through the principal focus. We do this line that goes through the center of the lens and the principal axis. And you see that they're never going to meet here. So if you now know how to correct this one, do it. What should happen is you should trace it back. You should draw the dotted lines behind, and then they will cross here. We can see here that this is a virtual image. And what that means is it's on the same side of the lens as the object. The image is on the same side of the lens as the object. So it's virtual, but it is upright and it is magnified. And there's another definition of virtual on here, which means that the light does not actually pass through it. Okay, so just check your table, and if you got any of those wrong, what I'd like you to do is just to skip back to where I just showed you those quick ray diagrams and see if you can see where you went wrong. If you got them all right, absolutely fantastic. You are ready to move on. So the final part of the Aspire objective we need to do is to be able to calculate the magnification. So all throughout these diagrams, we've calculated the size of the object and we've calculated the size of the image. And we've said whether it's been magnified or diminished, or in this case, the same size. If it's been magnified or diminished, you need to be able to calculate how much by. So this is how we calculate magnification. Now, you've done calculating magnification before. In biology, in the cells topic, it's one of the very first things that you do in science. So this isn't new, and it's just an opportunity to link, to make links to somewhere else in the science curriculum, and practice something that might come up on multiple exams. So this screen here looks pretty complicated, but it's not. There's a lot of information on because it's going to give you an opportunity to get really good at this. So the very top here, you can see this is my model. So what I've done is I've taken an exam question, and all you have to do in the exam question is to look at this image. Now you can see, as I've said earlier, that this is on squared paper, so it's going to produce a more accurate image than the ones that we're drawing here on our lined paper. So all I've done is I got a ruler and I measured these images. So that object, I should say image, that's an object. That object was 1.2 centimeters and that image is 3.7 centimeters. And then you just have to use this calculation, this equation. Now it's given to you, so you don't need to actually remember this. So you just need to put the numbers in. So you can see in my model here, what I've done is I've written magnification equals image divided by object, and I'm just going to put those in. So the magnification is 3.7 because that's just coming directly from there. I'm not putting the centimeters in because they're both in centimeters, so that's fine. And we're going to divide that by the length of the object, which is 1.2 centimeters, which gives us 3.01 on a calculator. And we can just round that to times 3. So it's magnified by 3 times. There are no units of magnification, so you can put the X there if you want to say that it's times by 3, but you don't need to. 3 would be a totally acceptable answer. So try and make your working out look like this. So what I've done in this table is we've done something which is called faded practice. So faded practice is just designed to take you from a really concrete example like this into one where you get confident so that you are able to answer questions that are more written like this. So on your book, let's just put A. And we're gonna work through this one together. So the first thing we always do is we write down what we know, the same of any equation. So we know in A, the image equals 6 centimeters. And the object equals 4 centimeters. Now in terms of highlighting a misconception, this is where pupils normally go wrong. They're normally absolutely fine with doing the calculation, but the problem is that they just forget which one is the object and which one is the image, and it's really easily done. So just check your answer, make sure you look at the question, proofread it, and you'll be fine. Okay, the next thing is to write down the calculation. So we can see it's up here in the top corner of the presentation. It's there. So we can just write mag, you don't need to write magnification each time, equals image divided by the object. Okay, so let's now substitute our numbers in. So magnification equals, so the image, so the size of the image is 6 centimeters, so we'll just put that in there. We don't need to write centimeters. Divided by, so we just follow that sign down. The object, so 4, so magnification is 6 divided by 4, and it's now up to you to fill that in. Okay. All right, let's have a go at part B. So part B, exactly the same. Now I'm not going to sit and do part B for you. That is for you guys to do. So all I've done is I've just taken out one extra thing each time on this faded practice to the point where we get to part C where you're doing the whole thing yourself. And then there's a couple of questions, D and E, and then a stretch one where we're talking about a diminished image rather than one that's been magnified. So pause the video, take your time, have a go at those questions, and I'll be back with you with the answers. Okay, I'm going to do the nodding head thing a little bit to give you time to pause. Okay, answers. Okay, this is what you should have done. I'm not going to read through them. You can read yourself. If you need more time, pause it. Have a look through those answers. If you didn't get any of those answers, go back to the last part of the video where I just explained what to do, and make sure that you are happy and that you are able to do this. Okay. So what we need to do now is we need to use this skill that we've just learnt here and put it into the context of what we've just been doing. So you have already drawn all of your ray diagrams. So what you need to do is go back to your table, so this one here, and you need to go and look back at your ray diagrams, look at the image size. So for instance, on this one, it was 2 centimeters, and look at the object size was 2 centimeters and the image size was also 2 centimeters, and then calculate your magnification. So for this one, which was at 2f, it would be 2 divided by 2, which the magnification, there's magnification of 1, so it's not magnified at all. Okay, have a go at that. Show you working out in each of those columns. Now I can't give you answers apart from that 2f one because it will depend on the scale that you've drawn your diagram. You'll all have different answers, but the idea is that you're just comfortable with that formula, and we're comfortable of calculating magnification. I've come to the big question, and by big question, what I mean is this is the question I selected at the very start before I started planning this lesson, and I thought if a student can answer this question, then they can achieve all of the objectives. They can do absolutely everything I wanted them to do. This is, the hardest type of question that you'd be given on an exam paper to do with this. So let's see if you can do it. And if you can do it, then brilliant. Okay, brilliant. You right now you can do this lesson. All right. It doesn't mean that you don't have to come back to it later. Just because you can do it now doesn't mean that you'll be able to do it in 6 months' time, 9 months' time, or in your GCSEs. But it means that you definitely got the capacity to do it again. So this is drawn on squared paper. Like I said, in an exam, it will be done on squared paper in order to get the scale right. But you won't have this exam question in front of you. So I'm gonna have to give you some things for scale. So what I've said is to use each square as 0.25 centimeters. And the reason I picked that is not because it's a nice number, but because it will fit on your page. So we're going to draw the principal axis together, and then you are going to try and figure it out. So let's go with this. So the focus length is 3 centimeters from the lens. So it's the same as what we were doing before. Let's give ourselves a bit of space in order to do this. So 3 centimeter focal length. So we'll draw our principal axis. We'll let's put our lens in the center. So how long is that piece of paper? About 17 centimeters. So if we do about 8.5, so about here. So we'll draw our lens. Now, part of the thing you would have to do in the exam is to be able to spot what type of lens that is, because it tells you it's a convergent lens, but we've not used the word convergent. So you have to spot what type of lens it is. Let's make our lens 1, 2, 3 high, and 1, 2, 3 below. So if you know, do it now. If not, this is something that you need to go back and look at. So I'm just going to tell you. So it's convergent lens, so it's a lens that does that. It's going to bring light together. So focal point at 3 centimeters. So there's 3, and there's 3, and that would be 3. You have to make sure you get these absolutely spot on. Any little error might lead to you getting this question wrong, not because you don't know what to do, but just because of the scale. And another 3. Okay, let's label those. F, 1 focal length, 2 focal lengths, focal length, 2 focal lengths. Okay, so the object is going to be 2.25 centimeters from the lens. So it's within F. So 2.25. So that's 2.5. That's 2. 1, 2.2, and then part way between there. So that is where we're going to draw the object. Because I've made that as 9 squares. I might actually just check that. No, I think it's 8 squares, isn't it? So it's not it's not 2.25. It's 0.25 times by 8. All right, it's 2 centimeters. So I'm going to change that very quickly so that we don't get confused. So the object is 2 centimeters from the lens. Okay, so it's not there, it is there. Let's get rid of that other one so we don't get confused. Okay, and I measured that to be how many squares high? 1, 2, 3, 4, 5, 6, 7, 8, 9 high. So let me just check. So we can see that I'm counting here. 1, 2, 3, 4, 5, 6, 7. It goes to the top of the point. So it's 7 high. So it'll be 7 times 0.25. The reason I'm doing this bit for you is because this is just a little bit of math. It doesn't tell you whether or not you can do this question, but scales are so important in science, especially when we're drawing graphs, so it's really important. So hopefully you are following along. So that was right, I was just checking. So 1.75 high. So we'll find 1.7 and we'll move an extra 1. So that's 1.6, that's 1.7, and a part of that. There. So your arrow, 1.75. So this is where the sort of error is definitely going to come in, is how accurately you have been able to do this. As I say, in the exam, it's going to be a lot easier because it's going to give you the piece of paper. Right, you are set up now. So I'm going to stop. I'm going to stop helping, and it's up to you to figure it out. I'm going to do one more thing. I'm going to tell you that this is the object. I'm going to tell you it's 1.75 centimeters, but that's it. Now I've stopped helping. Okay, I'm going to pause it and I'll give you the answer at the very end of the video. Okay, let's see how to solve it. So first thing is to draw your first line parallel to the principal axis. I'm going to zoom in so you can see. And then we go through the first focal point, which is here. Okay, so our arrows are going that way. The next thing is to draw the favorite line through the very middle. And you get that. And then you should notice, oh no, these lines here, these lines of light are never going to join. So they're never going to focus on that side of the image. So we're not going to get a real image, we're going to get a virtual image. So you trace backward. Let's start with this one. Trace back. So dot, dot, dot. Use the dot dashed line so that it distinguishes it from your other one. And this is why I said give yourself a bit of space, because I saw what was going to happen here. And again, we do it the same on this one. Back, 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 back. So in the exam, you get 1 mark for each of these lines that you draw. So that's 2 marks so far. All right, and then you just have to make sure, so this is the problem with the dashed lines, that you're absolutely positive that they're crossing. So they're crossing here. Okay, remember the top of the arrow, and we have to make sure that this is really perpendicular, so 90 degrees from there. Okay, put your arrowhead on, just to show which way up it is. So we've got an image that has been magnified, all right, and it's virtual because it's on the same side as the object. So there's that image. And what we need to do is we need to measure it in centimeters. So I was checking, yeah, that was 1.75. So this one is 5, I think. Yeah, it's 1.5 centimeters. for me. Yours might be slightly different depending on exactly how you do the diagram. So now we're going to do the calculation. So we have got the object equals 1.75 centimeters. The image equals 5 centimeters. We've got our calculation. So our calculation is given there. So magnification equals image divided by the object. Okay. Magnification is unknown, so we'll leave as magnification. The image here was 5. Hopefully you picked the right one. Divided by 1.75. Okay, if you, let's have a go. 5 over 1.75 equals, I got 2.857. So I'm going to round that up to 2.9 times. So it's 2.9 times larger. Now there will be, in the exam, a source of error. So you'll be allowed a couple of squares each way. So if you've got an answer that is probably anything from about 2.6 times larger to about 3.3, 3.4 times larger, then that will be absolutely fine. As I say, it's not going to be perfectly accurate because we're doing it on our lined paper in our books. All right, if you got this, brilliant. All right, this lesson has worked really, really well for you, and hopefully you know exactly now how to draw ray diagrams, how to what a convex lens looks like, what a concave lens look like, and how to calculate magnification. Okay, I will see you next time.